Hello and welcome to this applied ergonomics lecture 6. We were talking about the various different steps involved in studying the work study or a work system, where we actually looked into in principle 3 different steps. One was about the identification of the job or the process description or the process selection related to a certain task. Then we also looked at how to record critically through some different mechanisms like the flow charts, outline charts, so on and so forth. And then in the third phase we do some critical examination of what has been laid out in terms of all different motion sequences and even assigning time scales to those motion sequences and making it a time study. So in view of that, we would like to now start looking at the different charts which are there and how you can record different pieces of information in this current lecture. And this will be followed by 1 or 2 case studies of or examples of how to solve or how to assign, let us say do a time cycle analysis or do a time study on a particular job. And then this will be followed by again trying to understand some continuous flow process systems in terms of assembly lines, etc., where multiple such stakeholders or workers are associated, so that their synchronous timing is very critical to sort of attain different levels of efficiencies at which assembly systems do operate. And followed by that, we will try to get into individual types of systems where only manual labor is involved or man and machine is involved, or let us say for example all automated processes are involved. So let us first look at some of these recording facts, and I would like to reiterate again, and this slide I had described in the earlier lecture, just for the sake of recap I have involved this. So once you are completely determined about identifying a job or a process through a Pareto chart or some other mechanism through which you have the top 20% maybe causes of delays or wastage of a system which is already identified, then the question is that you look at such a task or such a process which has been identified to perform the motion and time study to make it more optimized, and look at everything in terms of good representation or recording of the different facts associated with the motions and the time scales which are associated together in such tasks of pre-identified tasks. So in light of that, we had said that the recording can be done through something which is known as a process chart, okay. And in the process chart there were various symbols which were described. For example, there was a symbol for the main operation, which would be the main step of the task. For example, if I am doing a drilling activity or let us say turning on a lathe machine, so the basic operation there is the drilling or the turning, etc., which is there. So then there is of course an inspection, which means that whatever you have done here in the job earlier, that you are checking, and so there are different symbols which we attached earlier between operation, inspection, transportation of the material between the various work centers. If there is any temporary kind of delay because of operating because of let us say waiting time associated with the materials or the operators, or some permanent delay because of storage issues, for example material not available, etc. So in that kind of, in light of all this, we had suggested that there are many different kind of variations which are available in the way that recording can be done or facts can be laid out, okay. And so in that event we had the first type of process chart called the outline process chart, which would merely combine 2 different kind of operations, namely the main operation and the inspection, okay. So this was what we meant by outline process chart. So it kind of gives the overall purview of what is a process and what is the inspection which is involved in defining the whole process. Then there is a 2-handed process chart which provides a synchronized and graphical representation of the sequence of manual activities of a worker. So how individual hand is behaving of let us say the left side or the right side is being recorded in terms of different activity sequences, and time scales are assigned to the same. So that is another way of looking at. Then you have a flow process chart which talks about recording of all events and sequences using process chart symbols, and marks the distance, time taken for completing an activity. So what I am going to do in the next few slides is to give you an idea of each of these charts and how they are laid out in real system. So for example, let us say we talk about outline process chart. This right here shows such a chart, which is for a riveted plate assembly, done for an assembly shop. And so typically such a outline process chart first should be identified properly, including what is the part number that we are looking at, what is the part name that we need to assemble using this kind of an outline process chart, then the location of the part. So basically exactly where it is being assembled, and also the method that is being used, and also related to who has charted this whole process and who has approved the process. These are also very important things, because this is recorded somewhere with multiple purviews or multiple, let us say, views into place. So in this particular case, the outline process chart typically shows two different sheets, particularly let us say sheet 1 and sheet 2. We also know plate 1 and plate 2, and these sheets have some particular specific dimensions, and the idea is that we want to do a rivet assembly over these two sheets. So take both the sheets, keep sort of lap one on the top of the other, and then use a sort of a drilling mechanism to drill for insertion of a rivet, and then forming the rivet head, so that you have a proper lock between these two sheets in terms of a rivet. So this is the whole operation, and for doing this we are having three different things which are needed. The sheet 1, which is actually coming out of a cold worked steel strip sample, which is about 30 millimeters wide and let us say 4 millimeters thick, and then there is a plate 2 again, which is again another cold work steel sample of the similar kind of width and thickness, and both are cut at different lengths. So for example, the first sheet is cut at 250 millimeters length, and the second is cut at 350 millimeters length, and so basically it is just overlapping one another. Okay, so it is an overlap between two sheets that will show later on as both the things assembled together. And then we have classified this whole process. So what is the process like? So you have one sheet which you are drilling separately, another which you are drilling separately, putting the two together, then bringing a rivet inside and forming, right. So these are the different steps associated with this whole task or this whole job. So I have now illustrated this in terms of circles which represent the operation, and inspection steps which are represented by the square. You remember in the process flow, these are the two different symbols which are being used as shown here. So the first operation is cutting. So cutting of plate 1 is at 250 millimeters long, sample is cut out of the whole steel strip. The second plate is cut at 350 millimeters, okay, and so you basically drilling. So there is another operation which has, let us say, drilling where there is, let us say, a certain hole size which is being drilled, and two numbers of these hole sides are drilled on both the sheets. So basically sheet 1 is drilled at two different locations, and sheet 2 is drilled at two different locations as well. And then in the first one, which is actually on the top, we have also another operation of countersinking. So basically the rivet head can go inside, and there is a planarity on the surface because of that. So we have done a countersunk, which we have machined on the top of the second head, and then we inspect both the samples, that is plate 1 and plate 2, for burrs, okay. And so we are assembling plate 1 into plate 2 at this particular point, where you are just overlapping after inspection the plate 1 which is cut with two holes, and both the holes having countershank profile, and plate 2 which is only drilled at again concentric locations where rivets can be inserted this way. And the two rivets which are actually again few diameters long, let us say, in this case it is 3 mm in diameter for example, and 10 mm long. These rivets are put together. So this rivet comes in here and are made to insert into the overlaying holes on the top sheet and the bottom sheet, and then we are inserting the rivets, okay, because the rivets are coming all the way to this location and getting inserted here, and then we are forming the rivet head so that there is a lock on both sides, and then again an inspection happens. So this whole activity is now listed into operations given by circles and inspection units given by square. So in this manner, any particular task or any particular job can be recorded in a very organized manner, and think of it, it's a huge onus, it's a huge responsibility to record it in an appropriate manner, and that's why multiple purview. For example, if you have charted something, a process engineer has charted something and it's supervised by somebody else, including let's say a shop manager or something, it's actually a multiple level checked documentation which is standardized in nature. So, there will be multiple views put in. Each task, each activity associated with the process comes down to this kind of a let us say a detailed representation for you to construct the whole process of the assembly, etc., where probably this component that I showed is only one in probably millions of other components which are going to get assembled. Okay. So, such huge amount of such process charts are needed for standardizing the whole process, but you have to understand, because we are talking about the top 20% areas which needs the process study improvement or the motion study improvement, that kind of limits the domain to a slightly smaller size that way. So, this is outline process chart. We have another 200 process chart, okay, where again the same thing, representing the right hand motion with respect to the left hand motion. This is a assembly operation that we are recording here for 2 washers and a nut fitted to a bolt. Okay. So, there are certain part numbers associated, there are operators who are associated, you can record them. Then you also give a time point which started the chart. So, the chart starts typically when both hands are empty and materials are in their boxes. Okay. So, that is how you define what is the start of recording this process chart, and then the chart ends when the assembly has completed. So, this is giving a span of what exactly the process is from and up to what extent the process is. So, it kind of domains the process into 2 different operations. You have a method which is being used, which is the present method or current method being done by the operator, there is no change, and then of course, the person who has charted it and also supervised should sign such charts. So, in this particular case, as I understand this, so if supposing the bolt is kept on towards your left hand side and both the washers and nuts are on your right hand side. So, the best idea would be to get both the right and left hand to simultaneously move, one to the first washer and one to the bolt, okay, and then you bring it again all the way after grasping the bolt and the washer to the position where you are assembling the bolt. And typically this position would be probably in order to address time issues, this position would also be probably just overhead or over the point where you are going to drop the assembly or we are going to use the assembly. So, you take the bolt and the washer and bring back to a convenient location, and then you are basically trying to assemble it. So, how we represent this? So, now there are symbols again, symbols for transportation is given by this arrow, again symbols for particular operation is given by circles, and inspection again is given by square, and then there are certain hold positions, etc., which indicates let us say a temporary delay in the the permanent delay in the case of let us say the material has to be held somewhere for an operation to be performed. So, these are permanent delay in the sense that unless the process initiates the requisition for getting the material in, the material has to wait. Okay. So, there is some kind of a storage delay, you can say, of the material. So, in this case what we are describing is what the left hand is doing. So, you have the left hand moving to the bolt, similarly simultaneously the right hand moves to the first washer, then you grasp the bolt, that is an operation, okay, and then pick up or grasp the washer, that is another operation, and then you basically move to the position where assembly is being done, and similarly move the washer as well to the position where the assembly is done. Now, the right left hands are basically doing the assembly. So, that is an operation, you are assembling it to the bolt, and then you basically hold the bolt washer assembly for the next washer and the next nut to come in. So, now your right hand is the only one moving and the left is not moving. So, this is a temporary delay, a permanent delay which is being done unless you have assembled the washer and assembled the bolt. Okay. So, then you move the hand again, the right hand move to the second washer, pick up, grasp the washer, come back to the position, assemble to the bolt, move to the nut again, pick up the nut, again to the position and assemble to the bolt, and you are basically representing in this terms of transportation and operation. And one can probably do that when the nut is being tightened, during that time the right hand also moves to the position where you have to drop the bolt, okay, and there is an operation just aside to the box where the nut bolt assembly has to be dropped, where you actually tighten and then simply drop by gravity or something, so that the bolt nut assembly with the washer goes in to the packaged box, which would again go for the further step. So, this is the 200 process chart. So, just as you made an outline process chart earlier, you now are recording the motion sequences of both hands in terms of transportation, operations, inspections, delays if any, in a very organized manner to split up this simple task of bolts and washer assembly. So, then there is also another kind of a flow process chart which is related to how the material flows between different stations. Okay. So, in this particular case we are talking about a gear manufacturing, for example, and then there is a particular part number which is involved, and the gear manufacturing comes from a bar typically, which is sent first to the cutting machine, then to the lathe, probably to a gear hobbing machine which actually cuts the gear splines onto the to the bar or the shaft, and then do some kind of a process treatment, let us say heat treatment of the surface, so that there is enough mechanical strength so that gear meshing can be initiated between these two gears, and then for example inspect at various levels what is the material property, what is the hardness based on these materials, and then storage spaces can be earmarked for storing the part for further use or something like that. So, basically this whole activity of taking a bar, turning it on or cutting it to a certain length, turning it on a, let us say a lathe machine, followed by again facing, drilling, rimming, whatever are the requirements, followed by again the gear hobbing on the top of that stock bar, followed by the hardness. These are actually a process sequence, okay, in which the material should flow, and material typically is that bar stock which is there. So, in this particular case also we are trying to summarize the machine shop's operation in terms of again operation, transport, inspection, delay and storage, these few different process symbols which are used. What is important about the material type chart is that the flow process chart is that it actually records both the distances that the material is moving as well as records the time scales which are needed for either processing the material or movement of the material or even weighting of the material. So, for example, in this case you can see that the proposed split up into the different operations are that exactly 5 times operations are being done, exactly 8 times transportations are being done between the different stations, multiple stations which are used for the gear hobbing process, and exactly 2 times inspection is being done. There are about 5 different temporary delays and 2 different storage delays or permanent delays in the whole process. So, if I looked at how this chart has been plotted, you see there is an element description, there is also a symbol based whether it is an operation, transport, inspection, delay or storage. So, it is a classification, and the element descriptions are the different activities which are basically used for this whole hobbing process. And while doing this symbol I can probably count and see that there are about 2 different inspections storage delays or let us say permanent storage which are there in the process, which is as dictated by this summary chart. Then there are at least about 5 different operations which are 1, 2, so these are the 5 different operations which are there on the particular material flow diagram. There are exactly about 8 transportation operations if I counted all these 1, 2, 3, 4, 5, 6, 7 and 8. So, there are 8 material transportation operations. Similarly, about 2 inspections, you could record this here, inspection 1 and inspection 2, and then about 5 temporary delays which are again recorded by these different points. So, you can see that the summary what is proposed here is what is from this chart coming out in terms of the different operations into which you are splitting the whole task or the job. So, let us say we have a 50 bar stock which is somewhere in the store, and we move this from the storage to a particular machine which is used for cutting this bar into a certain size. So, basically this is sent to the cutting machine. In the process we are moving about 15 meters, and then after that we take this all the way to the machine to cut the size. So, the machine cuts the size and it takes about 2.5 minutes to do this cutting action. So, exactly what is your requirement here is to sort of maybe gauge important time scales. Not all times are needed, sometimes you can for example I am saying it is a 15 meter distance. So, typically there is a certain rate at which the material will move and you are just not enabled to do anything about it. So, in such cases where times are not important, just leave it aside. Maybe a distance and time are sort of earmarking each other in a similar manner. So, again observing a time unnecessarily for this 15 meter fixed distance is something which is probably a repetition of the task. So, we better avoid it. So, you have to be judicious in your choice where you really want to mention the distance and time scales in this. Then the material moves from this cut machine to a lathe, and there are about 35 minutes again which takes sorry, it moves about 35 meters again within the shop floor to go from the cutting machine to the lathe, where it's basically again delayed by some time. So because there is some other earlier operation which is happening on the lathe, so it basically takes 1.8 minutes of delay for the material to load onto the lathe, etc. The lathe of course performs facing of the bar stock, drilling also, and some reaming activity on the bar stock. Then it is again turned on a lathe system which is kept at about 5 meters distance, which actually faces the other side and also turns to the respective size what is going to serve as a blank for the gear, okay, or the gear cutting machine. Then it moves another 4 meters, and so therefore there is a material movement here as is being linked here to the gear hobbing machine, where it has to again wait for a few minutes, okay. So we are not recording this because this is probably not a very critical step of waiting. In any event, they don't have any issues with in this particular operation. For a lot of wait time is not really felt at the gear, so gear hobbing machine. So now we machine the gear, and that's an operation, and then again send this gear for inspection. So the inspection is at a distance of about 10 meters again. So we are doing the material again moves to through 10 meters and waits there for some more time before the inspection can proceed. And then actually there is some inspection done, okay. So there is some temporary delay which is there because the inspection probably is not ready for catering to the new gear system which has come or the new gear unit which has come. So the inspection is actually now carried out, okay, and then this material is again sent back to the heat treatment department, which is at a distance of about 12 meters, and so there is some wait period there as well in the heat treatment, and then there is some hardening action being performed on the heat treatment. Again it's sent back to the inspection, which is another 15 meters away. Probably this is a different inspection. This inspection is associated with inspecting the quality of the heat treatment, and the job waits there for some time, and then inspection is carried out with reference to the hardness, and then again the material moves back to the spare parts where you can stock the gear that has been produced, okay, and it can be probably seeking a storage delay or a permanent delay till it is again up for reissuance to the next level. So there are different time scales assigned. For example, facing the other side would take about 1.8 minutes, okay, just as the delay or wait period happened on a particular lathe, okay, and then there is machining time of the gear which is about 4.5 minutes, which is of critical importance, heat treatment of about 0.5 minutes, which is again of critical importance. And so typically the idea is that the total distance and the total time associated with such a process flow of material is being recorded in the way that the material flows between different stations. So this in a way is important, because then the material movement can be a yardstick, and the distances moved can be either reduced, or the time scales which are associated with the various activities like weight or even let us say processing of materials on certain systems, those can be eliminated, so that you could have a proper idea of how optimization can be carried out of the material flow. So this is again a process flow chart. So these are the three different kind of charts which are now practically also explained to you about outline flow chart, then again two-handed process chart, and then finally the flow process chart for the material type as you are seeing in the current slide. So I would like to now close on this particular module, and in the next module we will look at probably some more things related to let us say flow diagrams, etc. Till until then, goodbye.